Hi everyone, welcome back to the Linux. Today we are going to see about Gaussian Naive Bayes algorithm. It is in a supervised machine learning and used for a classification task. And it's in a type of Naive Bayes algorithm. In the Gaussian Naive Bayes algorithm, it works on continuous variable, and also it will assume that each features are independent in each others, and each features in the each classes will separately follows the normal distribution. If you haven't watched my normal distribution video, I prefer you to watch that because it's a base of how the Gaussian naive Bayes algorithm works. I will give the link in the description. And in the Gaussian naive Bayes algorithms, will works on the continuous data as I told, and it will assume that each features in the data sets are separately follows the normal distribution. This is a probability formula we used for a name predict the values. For example, if I rewrite this equation mathematically, 2 pi variance to e power minus z, where z equal to x minus mean divided by 2 into variance square, where x is the input, where this x is the input, and this mu symbol is in a mean of the futures, and this is in a variance. This is in a variance of that future in that class t. And what does the function return? This function return the density of a data point, like it will return the density near the data points. For example, the future x of the normal distribution looks like this. Maybe let me draw correctly. The futures looks like this. If the data point x will occurs here, this probability function will return the nearest region density near that point. It will simply return the density of that data point region. Using that density, we will predict the probability and we will classify the data which class it belongs to. And the main advantages in the Gaussian probability is it works on a continuous data. Unlike some other probability function, most of the probability functions are works within a like categorical data, but in the discrete case. But in the Gaussian probability, it works in the continuous values and only real numbers. For better understanding, we will see how the model is trained and how it will evaluate our data points and tell which class the data points belongs to. For example, let us assume this is a data set we have. These are the futures and these are the labels. As I told, it's in a supervised learning. It will learn by an input and pairs of output. And there is two classes, right? Yes or no. There is only two classes. In this case, there is only two classes. And what the model will do was it will first it will find the mean and variance of the each futures in the each classes. In this case, there is only one future. Like there is only x here. If I if you want another features, like we have the another column and have some value like a b c, or if you want a numerical like 10 12 2 13 3 4, like that. But for simplicity, we will first stay on single input features. This is how the dataset looks like. The Gaussian naive Bayes model, what it will do was it will separate the data like based on the class. For example, in this case, it will first classify this data, like these are the S classes, right? First classify this data, and next it will classify this data. These are the separate two classes. It assumes that these are the separate classes because the labels are different. And in this class, it will separately do the operation like finding the means and variance. In this case, the variance is the mean is 6.5 for in a class 1. The variance formula is sum of the all the values in the future divided by n, where n is the number of values. For example, in this case, 6 plus 5 plus 8 plus 7 divided by, here it is 4, right? So it's divided by 4. It will, the answer will be 6.5. So the mean is 6.5. Similarly, we do for a variance. The variance formula is, we find the mean is 6.5, right? Of a class 1 is 6.5. The variance formula looks like summation of I0 to n and x minus mean the whole square divided by n. Here it is, the x minus x is the each values, and this is a mean we found out. Based on this, it will find the mean. For these cases, let me rewrite this. If you want to find the variance, like summation of I0 to n and x minus mu the whole square divided by n, right? It's like 6 minus first 6 minus 6.5 plus 5 minus 6.5, sorry, the whole square plus 8 minus 6.5 the whole square plus 7 minus 6.5 the whole square divided by n. If you calculate this value, it will looks like the value will be 1.25. Similarly, we do for an a class no, and the mean will looks like 2.5 and the variance will be 1.25. Both the classes have a same variance for this future. During the training process, it will simply find the mean and variance. After the training process, it will store these values like mean and variance for a classes within a respective futures, and similarly it will store the mean and variance for a class no class. And during the predictions, there is a new data, we need to classify that, right? For example, the data point x equal to 4.5, right? We need to compute it, right? First, it will, what it will do was, it will just pass this value into the two classes. Like we found the probability function, right? We found these means and variance for, because we need to substitute this in formula, substitute that in this formula. For example, for the future one, if I write the equation will looks like 1 by square root of 2 pi. We know the value of pi, and the variance, we found out is 1.25 into e power, and the value will be x, minus mean for this future is 6.5 and divided by 2 into variance, that is 1.25, right? Let me erase this. This is the equation looks for a future in the S class label. For a no class label, like for the no classes, there is another formula. I will write here 1 by square root of 2 pi. The variance are same, 1.25 into e power x minus, here this mean 2.5 divided by 2 into 1.25. Here it is minus. The x is the input, right? I have already told that this function will return the density near that new data point, right? It will just found the mean and variance. The only thing in this equation, or in this equation, we need a data point, right? X. If we need the data point, we can tell how much density it's there, or we can, for simplicity, we can say that how the probability there. For the new data point and 4.5, Here it is two classes, right? For this data point will goes in the this class also, and it also goes in the this class, this function also, and it will return the answer. For example, for an a s class for this data point, it will answer looks like 0.065, and the for an a no class and the future, there is only one future, so the probability looks like 0.176. Here it is. After finding this, we need to find the like class probability. For example, in this data set, there are there are total of 8 data data points, like data points, right? 1, 2, 3, 4, 5, 6, 7, 8 points. And for S classes, there are four there are four possible data sets. So the probability of S equal to 4 by 8, that is exactly 0.5. And similarly for an a probability of no classes, here it is, there is also four data points, and 4 by 8 and 0.5. The 8 is the overall data points. And both classes have an equal number of probabilities, that is 0.5. We found out that that is 0.5. After finding this probability, we simply substitute in the the formula. The formula is the probability of an S, sorry, X of S equal to, we found out that, right, there is only one future, sorry, probability of S classes of a data point X will be, look, this is a probability, conditional probability, and I will explain this in the normal distribution video, so you can watch there. And the formula is P of S into, sorry, let me write in the detail, and the formula looks like P of S of a given data point will be the P of S into P of X of S. In this case, there is only one futures, so the equation end here. If there is more than one futures, and we go on, like here it is an x1, and go for an a into conditional probability of x1 of given S classes, and divided by P of X. Here P of X is in a constant. For to remove that, if you remove this, we simply do the proportional symbol here. This is a formula looks like, and we substitute these values in here. For example, this is a probability of a class S, and 0.65, like you know, the probability of X given, sorry, the probability of X given S is 0.65. That's where you put there, and probability of S is 0.65. And if you multiply this is a value. I haven't written this formula here, so I written there. And we similarly do for an no classes, like P of no of a data point X equal to P of no into P of X given no, and divided by P of X. As I told, the P of X is in a constant, so we simply remove it. For that, so we remove it, right? For that, we simply put the proportional symbol here. And if you want to find the probability, we know the probability of P of no, that is 0.5. That's where we put there. And P of given X, sorry, P of X of given no classes is 0.176. If you multiply them, the answer will be 0.088, right? This is a probability. After finding it, which data points have an higher probability, here it is 0.8, is it has an higher probability, right? So the data may belongs to a class no. So the prediction of this data point, it is class no. In the summary, the Gaussian Naive Bayes, it's an effective for a continuous features, assuming that each features follows the normal distribution. During the training, it will learn class-wise mean and variables for an each features. If there is an n features like x1, x2, and x3, and the label, and it will find the mean for an x1. There is an n number of values like 1, 2, 3, up to an n. Here also some values 5, 6, 12, up to n. Similarly here, and it will find the mean and variance for an each features. It will find the mean and variance for this x1 feature, and also find the mean and variance for this x1 function, and also find the mean and variance for an this x1 function. And after finding it, it will during the prediction, it will use the Gaussian PDF to calculate the likelihoods, and the selects the class which has a maximum probability. As I told, here we are selecting the maximum probability, right? So in this case, it is in a class no. So we are class no have an higher probability. So we predict the class. It's like no, it is in a like it is in a no class data. Here we seeing the futures. There is a single futures in this class, right? For a better understanding, we will go for a next example. In that example, which has two features. Here it is. In this case, there are two features, x1 and x2, and there are also a label. And as I told, it will first separate the class S and no, and here also it will separate for a no class also. After separating these classes, and it will find the mean and variance for a separate features in the each classes. For example, it will find the mean for this data points, and also find the mean for these data points, that is 6.5 and 1.25, and it's also find the mean for these features also, and also find the mean for find the variance for these features also. Now I hope now you can understand slightly. And similarly, it will find the mean and variance for this data points also, and it will find the mean and variance for these data points also. These are the mean and variance for a respective features in the respective classes. After finding the mean and variance, next we go for an predictions. And in that, and there is one thing, and it is use the separate Gaussian function for an each features in the each formula. That means like the Gaussian function looks like PDF function, square root of 2 pi variance e power minus z, where z equal to sorry x minus mu divided by 2 into variance square. And this feature substitute the mean and variance in the this function, and separately this features also use this function, separate function, each have a there are two function now, right? And this feature use this function, sorry this features use this function, and this feature use this function by substituting its means and its variance to here it is. And here also by substituting its mean and variance in these functions, and for each features and the each class it's used in a separate Gaussian function. After finding the mean and variance and substituting the separate Gaussian function in the each features in the each classes, now the time to predict the data points. During the prediction, before the user give the inputs, right? Here it is in a two features, so the user give the inputs like two values, and we do the same, right? Like we substitute this value into the Gaussian function, this Gaussian function, and similarly we substitute this function, this value into this Gaussian function values for these classes. Like, you know, first we find the probability of an 4.5 in the S classes. In this case, we use, for example, let me erase this. You know, for each features, it will use the separate Gaussian function. For example, this is g of one of S classes, and this is g of two of S classes, and this is g of one of no classes, and this is g of one of S class. Sorry, no classes two. If I write the Gaussian function here, g of one of S class looks like 1 by square root of 2 pi into 0.5, 6.5, and z, sorry, e power minus x by, sorry, this is not 6.5, it's 1.25. Here it is 6.5 and 2 into 1.25 for an g of a first features. Similarly, for an a second features, 1 by square root of 2 pi into 1.25. Sorry, the variance will be differ. Here the variance is, I forgot that point. Here the same variance, the mean only 185, 1.25, and e power x minus 185 divided by 2 into 1.25. This is a Gaussian function for an feature 1 and feature 2 in the S classes. We similarly do for an class 2 and class 3. Sorry, feature 1 and feature 2 for an no classes. So in these first cases, we simply substitute the 45 in this year. We simply substitute the 45 here. The formulas, if I substitute that, after calculation, it will return values like 0.065, and if I substitute 4.5, sorry, and then if I substitute 150 in here, because here it is second feature, and we substitute in the second feature formula, that is this second feature formula. You can see that second feature formula, so that is 145, and it after finding the calculation, it value looks like 0.017. We similarly do for a no class also, and the formula, we need to rewritten this. I hope you can do that. And we found the probability as 0.176 and probability as for an NO classes, that is 0.24, sorry, 0.024, and the formula looks like, as I told, there is one classes, so I will write the formula there like one variable, but is here the formula will looks like probability of S of given feature looks like probability of S into probability of X given S, but here it is the X is in a two variable, like this is in a x1, this is in a x2, right? So we first we erase this. The formula will looks like probability of x1 and given S into probability of x2 in given x, sorry, S class, divided by probability of x. As I told, it will remove. Due to removing this, we simply do the proportional symbol. And after putting this value, if I like 0.65, as I told. The 0.65 is in a S class, that is data point 1, in proportional of this in 0.5 probability of S classes into, we found that probability of x1 in the given S class is 0.065 and probability of 150 in the S classes is 0.017. This is the exact we written here, and the probability looks like 0.00553. And for an no classes, we similarly do this operation for an no class also, and the probability will looks like 0.002110. And in this both, this class have an higher probability, right? Because there is a 30, and but here it is only 20, and 2 will found before the that. So it has a higher probability. So it predict that data points belongs to an AS classes. I hope you can understand how the model is trained, how it's having a predictions. Thank you. Let's see you on next video.